Okay, the context for what we're going to do here is provided within the course website, and you can get a little bit more of that at this site, with this document, or if you have the link to the course 1905-02 assignment. Okay, so a given composite, we want to identify the functions from which the composite is formed. I didn't write the whole statement. Again, that's at the website. So f of x is the square root of x squared minus 5. We want to identify the functions that go together as a composite to form this function. Okay, so f of x is going to be a composite of two functions, g and h. It's going to be the composite g circle h of x. Okay, now g circle h of x again means what? It means g evaluated at h of x. So we ask ourselves, okay, if you give me an x, how am I going to evaluate f of x? Well, that's pretty easy. You plug in the value of x and you square it, and then you subtract 5, and then you take the square root. Okay, well, x squared minus 5 isn't a composite, it's just a plain old function. It's an x squared minus 5 function. And I don't want to go into too much detail about what comprises that. The questions here should be fairly straightforward. Okay, so anyhow, the first thing you do when you give an x is you do x squared and then you subtract 5. And then you take the square root. So if you do g circle h of x, well, that's g of h of x. If you give an x, what's the first thing you do? You evaluate h of x. You plug it into the h function. So the first thing you do is x squared minus 5. The first thing you do is h of x. So h of x had better equal x squared minus 5. Now, what's your g of x? Well, h of x is going to be x squared minus 5. If you apply g to that function, you should get the square root of x squared minus 5. Well, so if g of x is the square root function, that's going to do it. Now let's just check it out and make sure that it really is so. Okay, g of h of x is what? Okay, well, g of x is square root of x, so g of h of x has to be the square root of h of x. We've replaced x by h of x to get this expression from the g of x. And if this x is replaced by g of x, we've got to replace this one by g of x. So g of h of x is the square root of g of x. But what's g of x? It's not g of x, it's h of x. Sorry for the misdirection there. Okay, again, g of h of x, we plug h of x in for x, and we plug it in here, and we get the square root of h of x. Then, what is h of x? Well, it's just x squared minus 5. So if g of x is this and h of x is this, then g of h of x is this, which is our f of x, and now we've expressed f of x as a composite. And this is a very important thing for many applications. Composites are important of their own right. If you move on into calculus, you're going to have to be able to identify composites to apply one of the big rules, called the chain rule. Okay, so the other topic here, and I'm going to move this little sign here, whatever it is, identify the type of an equation. So, for example, this is a quadratic equation. And it's in the form ax squared plus bx plus c equals 0, to which you would apply the quadratic formula. Now, you can also solve the equation by factoring if the thing factors, but you find that this doesn't. And from the quadratic formula, you find that you have complex conjugate solutions. But anyhow, that's a quadratic equation. So that's an example of a quadratic equation. Now, power function equation. 5x to the 2/3 equals 9. 5x to the 2/3 is a power function. A power function is the form ax to the p. And in this case, a would be 5, and p would be, the power would be 2/3. So this is power function equation. Equation that looks pretty much similar to this is like 4 times 1.5 to the x equals 5. Okay, this one has a solution you can easily find, but you can't always do that. Okay, this would be an exponential equation, because 4 times 1.5 to the x is an exponential function. You'd have a logarithmic equation. Okay, so it's a logarithmic. Equation. Now these should be fairly easy to identify. And how do you solve a quadratic equation? Well, we use the quadratic formula. So I could say, just use a little contrasting color. Okay? Now this equation, you're going to put it and ultimately then, once you have it into a form like this, you take the reciprocal power of both sides. An exponential equation, how do you do an exponential equation? Well, this equation we would put into the form (1.5 to the x equals 2.25). And then, now we could do this by inspection, because I know 1.5 squared is 2.25, but that's kind of a rare occurrence. And then you would change to the logarithmic form. X equals log base 1.5 of 2.25. And then it's easy to solve because it's a log of 2.25 divided by the log of 1.5. It's one of the properties of logarithms. For logarithmic equation, and let's be a little more inventive here. Let's have 5 log of x squared minus 2. You put this into form. You know, this chalk is getting hard to write with. Let's do this. Put it in logarithmic form here, and then you can immediately change this to the exponential form. This is an log log, which is a 10 to the power, log base 10. So you would get and it's not log base 10 of 2/5, it's 10 raised to the 2/5 power. Let's see if I can manage to erase this. Somewhat neatly. So it's 10 raised to the 2/5 power. Better written, more clearly written as 10 to the 2/5. Okay? So you have to identify what kind of an equation you have before you can solve it, because there's a different way of solving every type of equation you might run into.